So thank you for the invitation. The question you can read actually came up in Sicily. There was a meeting, and I think Alan was one of the reasons why this question came up. Oh, why this question came up. And as a consequence of this Sicily meeting, we made a proposal to ISI, and a large team then met at ISI 2 times and wrote something on plumes. It's 70 pages long, so I have to somehow select something in 10 minutes, and I will select those items where Alan was deeply involved. He was involved in everything, but he was deeply involved in at least one item. So we heard about plumes. Here you can see the plumes in a nice eclipse photograph by Pasakov. And of course, since EIT has to come up somewhere, we inserted, I think Luca did it, inserted an EIT image into the eclipse corona. Some people said now the image is spoiled, but I think it's a nice combination of an eclipse photograph and EIT. You can see the plumes coming out north and south of the coronal holes, in particular in the north. You can see the coronal hole and the plumes. So this is what we are talking about. It's a little bit different from what Brigitte just said, I suppose. Now, this is the team at a meeting in Bern. Alan is in the foreground, and some are in the back. A few people are missing. And in addition, I included a little sketch from Antoine Lebaria, or these people talking about plumes. I'm a bit skeptical. It's probably the hen that is saying that. Okay, there are many things that are very sure about plumes. I mentioned a few of them, and the team I just showed agreed on those more or less. Plumes basically show you the magnetic field lines coming out of the quiet corona near the poles. They expand super radially. There was some discussion whether they are radially, but it's quite clear they are super radially expanding. And of course, they are plasma densities. There is no question about that. I think we agreed on a density ratio between plumes and interplumes of about 3 to 7. Depends a little bit on the height. The temperature in plumes, the electron temperature is quite low, less than 1 million. It's higher in interplume regions. The ion temperature is much higher. And I think the last point, oh, I'm sorry, this is the wrong one. The last point here, no, the second one. The question that came up really is the outflow velocity in plumes higher than in interplumes regions. Basically, this is related to the question, is the solar wind coming mainly from the interplume region in the coronal holes or in the plumes, or both? I think we will hear more about this later on. But one thing, the last one here also was quite distinct. Plumes and interplume regions have different abundance compositions. So I hope now I pushed the right one. The one item that was the basic reason for this meeting, I think, is shown on those 2 diagrams, one from EIT and one from stereo. At that time, we had only EIT. And Alan noticed that plumes basically scatter on the backside of the sun. So we have 4 images of the sun 1 week apart. And on all those images, you see basically the plumes brighter on the rear side of the sun, which of course cannot be. So the idea was beam plumes, plumes that really come from here. You see the source here. Sometimes it's a bright point. You can identify. And since most of the plume stuff is from behind the sun, Alan had the idea that you see curtain plumes. Basically, they are curtains, and you can only see them when you look at them along the plume, and you don't see them when you look through the plume. So this was the idea when we started the discussion in Bern. And the same thing was then later found on stereo. Most of the stuff is from behind the limb. But of course, there are some beam plumes. And the beam plumes were quite interesting for us, in particular with the stereo data we had at that time, because you could then try to have 3-dimensional constructions, but only this works only for beam plumes. So Li Feng, at this stage, did try to reconstruct some of the beam plumes she could identify on both stereo spacecraft. Those are the beam plumes she identified. And the construction then is shown here. So it's a little bit difficult to understand, but here is one view, and here's a view from the pole. So you could really find the location of beam plumes, and there's no question about the existence of beam plumes. But there is also this question of what causes most of the plume brightness from the rear side of the sun. We come to this in a minute. With SUMA, we then realized that plume, this is the sun here. Here we have the corona. This is the density, plasma density, for the ratio measurement, silicon 8, I think it is. So here is a bright plume, and there is quite distinct abundance difference here between neon and magnesium. Neon being a high Fib element, a high first ionization potential element, and magnesium a low one. So in plumes, the low Fib element is much more abundant than the high Fib element. Now, the brightness of the rear side of the plume stuff. This is taken from Allen's paper 2009. He had several before, but I think this is the best one I found in this context. So if you scan across the limb is, by the way, the dashed line here. Above the limb and below the limb, you find a major difference in plumes. There are much more plumes, obviously, behind the limb than on the limb. And as I mentioned before, this cannot be if there are only beam plumes, because they should be scattered around the coronal hole. So the idea of Allen was first the curtain plume. And then there was another measurement from SUMA. Oh, yeah, he did some calculations, the model calculations of beam plumes. They should just extend from the corona into the coronal hole on the disk to a certain foot point here. There's another calculation here. And observations are shown here. Those plumes actually exist, as we have seen. There are beam plumes, there's no question about that. If you have curtain plumes, you would experience a drop of a factor of 2 at the limb, because you see twice as much before the limb than after the limb. And in fact, there are observations that correspond to this drop here as beam plumes, as curtain plumes, I'm sorry. Now there is an observation from SUMA, which is a little bit complicated, but the important point is, again, this is a density line, silicon 8, and on all those scans, we see that those lines do not cross the origin. Now, if you have one plasma and you look through one plasma, you should always end at the origin, of course, because both lines should go down at the same time, but they are always off the origin. And we then discussed at the meeting in Bern that this can only be if there are two plasma regimes in the coronal hole, a dense one, being plumes, and a low density one, the interplume region. But how can you combine this with curtain plumes? And then Allen came up with the idea, there is not a curtain plume, but there are micro plumes aligned as a curtain. And the alignment was then along the network, so eventually I think the network plume idea came up. Anyhow, we have now micro plumes building curtain plumes, but they could, of course, also be beam plumes in another configuration above bright points. This is basically, I think, the end of my presentation. So we have micro plumes and network plumes, we have beam plumes, and there are some open questions, and I think we will hear about them in the next 2 or 3 talks. Thank you.